Quiz 1. By the way, we've barely scratched the surface with what we can do with forces, but we can already handle some interesting situations in my mind. Who's my favorite student? Sorry, not any of you. Good old Anne. She gets everything right. You know what? Number 1 being 2 marks, I'll do this. I'll get the second part. What's the unit of force? What do I measure force in? Newtons. So if you did a capital N or you wrote N-E-W-T-O-N-S, that gets you 1 mark. What's the definition of a force? What did I say a definition of a force was? Do you remember? I said it was a something or a something. You know what? If you said a push or a pull, I'll give you 1 mark. If you said something else, now's your chance to ask. Did you say something else? Ask me, and I'll probably say yes. Anybody say anything else? You could say, yeah. I have to be really fussy and say no. If you had said causing a changing movement, like an acceleration, yes. And you're going to learn later on this year, force isn't energy. That's a completely different idea. But if you had just said something that causes an object to accelerate, I would have said sure. But movement, can you keep moving in outer space without a force? That's how outer space works. So if you give something a push and let it go, it will keep going in a straight line at a steady speed. So I'm going to be fussy and say no, but do your correction and get the mark, and then you'll remember that definition properly. Anything else? No one's going to say anything now after Okay. I think I told you the key word here, net force. That means I can go straight to F equals MA. So it's going to be M 1200. I didn't do winner minus loser or a free body diagram or anything. Is it 2,400 newtons? Is that correct? 1 mark. It wants me to find the force. I'm going to go F equals MA. I noticed they gave me M, but they didn't give me A. So I said, okay, I'm going to need to find the acceleration. A equals question mark. Well, VI is 0 because it says starting at rest. VF, Mr. Dueck, not VI, VF is 770, and they gave me a distance of 1.5. Hey, I said to myself, I can use A equals VF squared minus VI squared all over 2D. I can go 770 squared minus 0 squared all over 2 times 1.5. I got an acceleration of I didn't bother typing the minus 0 squared because that's not going to make a difference. Divided by bracket 2 times 1.5. I got a huge acceleration. At first I got nervous, but then I said, wait a minute, what's the distance in this question, Antonio? 1.5 meters is about this, if I'm holding my hands apart like that, little, 1.5 meters. And we're going from 0 to twice the speed of sound in that distance. Would that be a fair bit of acceleration? So that number there didn't scare me once I thought about it. I said, actually, that looks good to me. So I wrote down 197633 because this isn't my final answer. And then I walked over to here and I said, okay, it's going to be 65 times, I'm going to write 197633, but what button am I going to use there, folks? Answer button. So I went 65 times answer button. You got a huge answer. Well, you should. This is an artillery shell. 65 kilograms. It's about 140, 150 pounds. So a medium-sized human being or a small human being, if you're looking for a size comparison, a mass comparison, and you're launching them at over twice the speed of sound. There's a reason why artillery shells do so much damage. By the way, because you've applied this much force to the shell, once it hits its target, it's going to apply approximately that much force to its target. It's going to do a lot of damage. So I got I'm going to go scientific notation. 1, 2, 3, 4, 5, 6, 7. I'm going to write it as 1.28 times 10 to the 7th newtons. Is that correct, folks? 128461666.6 repeating. Okay, if you got that, 3 out of 3. Otherwise, I would probably do something like this. I would give you a half mark for F equals MA, half mark for the numbers, a half mark for the answer. I would give you a half mark for VF squared equals VI squared plus VF squared minus VI squared all over 2D. I would give you a half mark for the numbers, and I would give you a half mark for the acceleration. There's your 3 marks. Good yawn, Jackson? What's the second word in number 4, Jackson? I can go F equals MA. Jackson, what are they asking me to find in number 4? So I guess I'm going to go F over M. F 12 over 1.2. Is it 10 even? Meters per second squared. I put the decimal because I like to go to 2 or 3 sig figs, and technically a 10 without the decimal there is only 1 sig fig, but I'm fine if you didn't. Then I went to the next page. Savannah, what's 5A asking me to find? The average what? And this is now tough, not because it's tough, but because I've got like 10 ways to find acceleration. And so that's why you'll always hear me tell you what my brain thinks. So my first thought was, am I going to use VF and VI? I looked, I don't see any of that. In fact, I think I was talking to you earlier and you said to me something like, Mr. Dueck, there's a mass. Ooh, there is a velocity. There is a time. I am going to use velocity and time. Okay, even though they gave me a mass, they didn't give me a force. I'll bet you I'll find force in part B using part A. That's just a guess without even reading. So I said, okay, A equals question mark. Looks like V final is 3.2 times 10 to the 4th. Looks like time is 32. V initial, it does say from rest. So I can go VF minus VI over T. It's going to be 3.2 times 10 to the 4th. All over 32. Is the answer 1,000? I'll put a decimal. Well, whatever. That's to 4 sig figs. But 1,000 meters per second squared, 1 mark. And then it says net force. Okay, I can go straight to F equals MA. It's going to be M 4.5 times 10 to the 4th times 1,000. And you get 4.5 times 10 to the 7th. Newtons. You get a 4, a 5, and then I think you get 6 zeros after that, yeah? If you write it out, but I went scientific notation here. Am I right, I think? 1 mark. If you got the acceleration wrong here, but you went 4.5 times 10 to the 4th times your acceleration, I would give you 1 full mark for part B. I would give you 1 out of 1 because you did the method right. You just started with the wrong data value. D, huh? Okay. Well, I see VI is 0. I see VF is 12. What else would I like if I was trying to find D? What else do I need if I want to find the distance? Oh, A, you say. So I'll put a blank there saying I really need to fill in the blank first. I said, okay, well, F equals MA. They gave me a force. They gave me a mass. A is going to be F over M. It's going to be 1.6 divided by 6.4. Did you get an acceleration of 0.25 meters per second squared, or 1/4, but I'll make it a decimal. So I'm going to put that there. And now I think I can go D equals VF squared minus VI squared all over 2A. It's going to be 12 squared minus 0 squared all over 2 times 0.25. I can do that in my head. 12 squared is 144 divided by 0.5. 288 meters. Check for correct units. If you got that, 2 out of 2. Otherwise, I would probably do something like this. I would give you a half mark if I saw that, a half mark for that answer. I would give you a half mark if I saw that, and then a half mark for the answer. Again, if you got the wrong acceleration, but you went 12 squared minus 0 squared all over 2 times your wrong acceleration, and you did that correctly on your calculator, I would give you full 1 whole mark out of 2. Time. Oh. I got at least 3 ways to find time. I can use VF equals VI plus 8T. I can use D equals bracket VI plus VF over 2 times T. And I can use D equals VIT plus a half AT squared. You know what? I'm going to use T equals VF minus VI over A. It's going to be 12 minus 0 all over 0.25. 48 seconds, is that correct? I don't know why I made that 2 marks, but okay. 1 mark for the equation, half mark for the numbers, half mark for the answer. Turn the page. A book is sitting on a level desk. Which of the following statements are true? There are no forces acting on the book. That's false. Gravity. Get the obvious. Oh, and I guess normal force. The magnitude of the normal force equals the magnitude of the gravitation. Yeah, that's true. Otherwise, it would be sinking into the ground like quicksand or flying into like Superman. The net force is equal to 0. Is the book accelerating? Then the forces must be, I'm looking for a word that means letter B. And the fancy way to say that is the net force is equal to, yep, that's true. Friction is what's holding the book on the desk. Whenever you ask me a friction question, if I'm not sure of the answer, Rowan, I'll imagine that the desk is made out of ice and then made out of sandpaper or glue. I go to either extreme. If your desk was made out of ice, could the book still rest on there without sliding off as long as the desk was level? Yeah, friction is not what's holding the book on the desk. It's not required at all. So the correct answer here is FTTF. Half mark for each of those, FTTF. I guarantee there's going to be elevator questions on your test. We're accelerating up. This is a job for a free body diagram. What are the forces acting on me? Get the obvious one, gravity, but then there must be an unbalanced force up. It's the scale, which pushes up with the normal force. Who's winning? Normal force. Who's losing? Gravity. What's that going to equal? MA. So in part A, I get MA plus MG. It's going to be M, 60. A, 1.2 plus 60 times 9.8. I can do that in my head. This is going to be 60 times 11. 660 newtons, yes? What if instead of saying, tell me the answer in newtons, what if I said you're still standing on a bathroom scale, but it's not a physics scale that gives answers in newtons, it's a regular scale that gives answers in kilograms. How many kilograms would the scale read for that person there? How would I figure that out? Take that number and do what? Times by 9.8? Because if you times by 9.8, you're saying that the person is weighing that many kilograms? Is that a realistic weight for a human being? So you would catch it, I hope. I don't mind you making that mistake as long as you looked at your answer and went, that can't be right. Yes, divide by 9.8. So the scale would read 67.3 as opposed to 60. This person feels heavier. Are they heavier? No, and that's why I've said what's changed. It's the normal force, which we also often call your apparent weight. Your true weight is mg. The obvious one. Now we're accelerating downwards. Oh, for 2 marks, sorry. I would give you 1 mark for that, half mark for that, and a half mark for the answer, but if you've got the right answer, 2 out of 2. Get the obvious one. Normal force. Why did I draw normal force smaller? Who's winning? mg. Starting to see why I said a free body diagram really bails you out of a lot of memorization. It's a very, very useful tool. Minus normal force equals MA. Swappy dance. Plus that there, minus that there. I get mg minus MA equals the normal force. So the normal force is going to be M, 60, G, 9.8, minus M, 60, 2.25. 60 times 9.8 minus 60 times 2.25. Y'all get 453? Units, it's a force, newtons. I would again give you 2 out of 2 if you got that. Otherwise, 1 mark for the equation, half mark for the numbers, half mark for the answer. What 2 words would I underline in part C? Constant velocity. Because what's my acceleration then? 0. Who's winning? It's a tie. In my free body diagram, I would have this. Gravity equals normal force. It's a tie. Your arrows would be the same length. And so the normal force is going to be 60 times 9.8. 60 times 10 would be 600. It's going to be 600 minus 12. Is the answer 588? Two out of two if you got that. Otherwise, 1 mark, half mark, half mark. What would the scale read if I stood on it in free fall? 0. What would the scale read if I stood on it while I was on the International Space Station? 0. Why? Because the International Space Station is also in free fall. Why doesn't it hit? Because it's also moving sideways at just the right speed so that it matches the curvature of the Earth and just never gets any closer. It's trying to fall, but it keeps missing the Earth, which is kind of a weird concept. That's how orbits work. If you said 0, 2 out of 2, we did a proof in the homework, I think, in the notes. We actually said, well, let's assume gravity is winning, and you ended up with 60 times 9.8 minus 60 times 9.8, which is 0. So I'm not too fussy how you get there. If you now memorize that, you can, or you understand that, you can. Can you give yourself a lovely score on the test out of 23? And if you need to lawyer with me, now is the time. Folks, can you get out lesson 2? Now, if you already handed this in, great. But I did say that I would take questions from the homework. I'm going to do number 3. I'm also going to do question number 9, this free fall rock climber question. And then if you have any other questions to ask from lesson 1 or lesson 2 or lesson 3 or lesson 4, this is also your chance to ask. Then I'll press pause and the rest of the class is going to be yours to kind of work on stuff and get stuff done. So let's look at number 3. Looks like this. Why is question number 3 from lesson 2 so yucky? Lesson 2 comes after 1, before 3. Nombre dos. Find it okay, Courtney? You're all looking really puzzled here. Has you got the question okay? Yeah? Okay. Folks, what makes this one so ugly? Why? Why do you hate it? You know what? Even more obvious than that, no numbers. This is algebraic. And we do a lot more of that in Physics 12. A lot of the time in Physics 12, what you'll hear me say is, well, why would I use numbers when we can just do it algebraically? We've got a general rule that works for anything. Okay? So I am going to nudge you to get a little comfy. That's part of what this whole formula manipulation shtick has been. So here's what it's saying. Assume the force F is the only horizontal force on the block. If the first block accelerates A at rate A, then find an expression for the unknown acceleration. Now, you can do these purely algebraically. I would. But I recognize that some of you aren't there yet. Savannah, we can make up nice numbers. And by nice numbers, I mean don't use 19, a prime number that nothing goes into. Never use 1, because when you multiply by 1, you get the same answer, and you might notice a pattern that actually isn't there. I go with 12, 24, and 48, because lots of numbers go into those. So I'm going to let this force here be 24 newtons. Okay? In other words, Courtney, wherever I see the letter F, how big is the letter F exactly as a number? Okay. So how big is this F right here? I did that as well. And I'm going to make a nice number up for the mass. If you can't find it, just kind of zone in here, Rowan, but hopefully you can find it. I'm going to make a nice number for the mass. Courtney, can you pick a nice number for the mass? And do me a favor, how about something that goes evenly into 24, just so I don't have to pull up my calculator? Make up a nice number. 48 goes evenly into 24?
12.
12? Okay. So first of all, do you see what we did? Rather than do algebra, we made up nice numbers. You okay with that? How big does A have to be? If F is 24 and M is 12 and F equals what MA, how big must A be with the numbers that Courtney has made up? Huh? Got to be 2. Because 2 times 12, MA 24. You okay with that, Courtney? Okay. What did we say F was in our made-up example? 24. Courtney, what did you say M was?
12.
What's 2M then in your head? What's this acceleration, the mystery unknown acceleration? If I have a force of 24 newtons and I have a mass of 24 kilograms, what's our acceleration? Sorry? 1. MA. So you ready? You ready? Here's the punchline. What was our original acceleration? What was our new acceleration? What was our original acceleration? What was our new acceleration? When we double the mass, what happens to the acceleration? Half as big. That's why it says A over 2. Okay? That's the general pattern. But if you're stuck with the general pattern, Logan, because you're not comfy with the algebra, make up nice numbers. We're going to do it again, Logan. F is going to be, again, 24. M is going to be 12. Logan, if F is 24, what's 2F?
24.
No, F is 24. What's 2F?
48.
Yes. Yes? Same M, it says in the picture, so I'll put a 12 there. If my new force is 48 and my mass is still 12, what's my new acceleration? Oh, what was my original acceleration? Again, it was 2. What's my new acceleration? 4. When you push twice as hard, what happens to your acceleration? What's the pattern? How many times bigger exactly? That's why it says there for the second question, 2A. Okay. In Physics 12, on every single test, I put what we call a using principles of physics right to explain question. I put a proof. I'll say something like part B. Okay, suppose now the mass is tripled. Are we going faster or slower? And convince me. And I expect kids to kind of do an algebraic proof, but they can also make up numbers and just crunch the numbers. So that's number 3. That's a tricky question. If you still find that tough, you're not alone. 9 is fair game. What I mean by that is I would have no problem putting number 9 on a test. Most kids have asked me about D, but let's walk through it. A says find the speed. I'm going to do A right here. It wants VF. What's VI? What's VI for any rock climber if they slip and fall? I've never seen a rock climber take a running dive, so 0. The rock climber is in free fall, so it's negative 9.8. It is negative because that's what we called it 2 units ago. Is that 1.25 seconds? Is that how long the rock climber is in free fall? Read carefully. What is that 1.25 seconds? How long it took the rope to do what? To make him fall? Not to make him fall. To bring the climber to a... That's the bottom section after the free fall when the rope starts yanking on him. So I can't use a T equals 1.25. What else haven't I used? Riley? I think I heard you say it, didn't I? More specific. What is the distance? Don't say 10 because that's wrong. What? Thought I heard somebody say it. Negative 10 because we're ending up below from where we started. That'll get you A. You'll use VF squared equals VI squared plus 2AD, and that's where the 14 comes from. Okay? B, write a net force equation. That's always a job for a free body diagram. So here's the climber. What are the forces acting on him? Get the obvious one. Gravity. This is when the rope is bringing him to a stop. Antonio, this is your... Ready? Which way is the climber moving when the rope... Down? When the rope starts to yank on him, does the rope make him speed up or slow down? So if he's moving down and slowing down, which way is he accelerating? Which way is the bigger unbalanced force going to be pointing? Which way is he accelerating? Which way is the bigger unbalanced force going to be pointing? It's the same question, folks. That's Newton's first. So I know that tension from the rope is bigger, and that's how I know that the equation is tension minus mg equals ma. C, find the acceleration. Okay. A equals question mark. Now I can use that 1.25 because that's how long he's decelerating for, how long the rope is bringing him to a stop. What else do I know? Bringing him to a stop. What else do I know? Bringing him to a stop. What else do I know? VF is 0. What else do I need? You know, VI would be nice. What's VI, Jabber? I thought you said it. What? Isn't that V final? Oh, no. V final at the end of free fall is V initial when the rope starts to yank him to a stop. We've seen that happen before where a final in one section became the initial of another section, yes? So VI is going to be 14. Negative 14? I'm not sure. I'm going to leave it as positive, and I'm going to look at my answer carefully when I crunch this. Okay. Carlos, what do you want me to find?
Force.
Which force?
From the rope.
Which is what in my free body diagram?
Normal force.
No, there's no normal force in my free body diagram, and there can't be one. He's not touching a surface. Sorry? Like you're feeling right now? Tension? So I'm going to take this equation right here, which came from this free body diagram. I'm going to get the T by itself. Tension is going to be mg plus ma, or ma plus mg. There's the mass. There's g. There's the mass. Which A? My answer from part C is going to go right there. Mr. Dueck? Yeah, Ben? How come it takes the rope so long to bring him to a stop? Because 1.25 seconds, that's yank to boom. Like, that's a long time. We don't want the rope to jerk you to a stop because that's what breaks bones. The bigger we can make T, the smaller the acceleration you're going to deal with, the easier it is on your body. So rock climbing ropes are actually designed to have a fair bit of flex in them. They're not bungee cords. We don't want them that much flexy. But we don't want them to be instantly bringing you to a stop. That's going to do a lot of damage. Is that okay for number 9? Okay. Antonio, I think you were one to ask me that. Is that okay for number 9? Yeah. Thumbs up. Any other questions from any of the homework anywhere else? Now is your chance to ask. Yeah. 14 from same lesson? Okay. Cool. I like number 14. I like number 14. I like number 14. Number 14 is the next question. What does he want you to find? This is a job for a free body diagram. What are the forces acting on this box? Get the obvious one. Is it sinking into the ground like quicksand? Is it flying into the like Superman? So we must have a normal force pushing up. What else? Well, there's tension this way because it's the rope. And then there's this 18 newtons this way. I don't know what to call it, but I can tell you how big it is. It's 18. Look at the arrow drawn beneath the word or the acceleration. Which way is this box accelerating? To the? Which way is the winning direction? To the? Which way is my bigger force going to be pointing? To the? Okay, you figure it out now. Those are all the same questions. Who's winning? Who's losing? Don't overcomplicate it. Read me the number sitting there. No. Who's losing? Yeah. What's that? What's winner minus loser always equal? Good. What are we trying to find? Plus the 18 over. I would also have no problem giving you the tension and saying find the acceleration. Here I gave you the acceleration. I said find the tension. I'd have no problem giving you the tension and get the A by itself. Divide by M. You take it the rest of the way yourself? Yeah? So it's going to be 12 times 2.6 plus 18, whatever the heck that is. Any others? Going once, going twice.